Well, hello and welcome back to Distributions 1. So here we're looking at strongest performer. Kayla and Drew are both competing in a statewide fitness challenge that awards points based on vertical jump height. Each athlete gets 3 attempts, but only their best jump counts. In Kayla's region, jump heights are normally distributed with a mean of 21 inches and a standard deviation of 2. So she is in the 95th percentile. Aha. So we're given the percentile, and we are trying to find, let's look. In Drew's region, jump heights are normally distributed a mean of 24 and standard deviation of 3. He's in the 80th, who had the higher vertical jump. So we're given the percentile, and we're trying to find x. Whenever you're given the percentile, you're trying to find x, so you're over here, p of x to x. And percentile is always looking left, so the shading is left. Population mean is 21 for Kayla. Expected variability is 2. Raw value is what we're trying to find. The z-score we need, but we are given the probability. She's in the 95th percentile. And so working backwards to the z-score from the percentile, looking left is norm.s.inverse. Of that probability. It gives us our z-score, and then to get the x value, x is always going to be z times standard deviation plus mu. So z times the standard deviation plus mu. That converts the z-score back to a raw score. So 24 inches. All right, and now let's look at Drew. Shading's also left. Population mean in his case is 24. Expected variability is 3. We're trying to find x. We don't know what it is for Drew, but we do know that he's in the 80th percentile. So the big question is the 80th percentile on the black scale better or worse in terms of jump height than the 95th percentile on the red scale? We're about to find out. So norm.s.inverse, and the value that corresponds to is equal to that times the expected variability, or the sigma, plus mu, so 27. So Drew's jump height is 27, even though he's in a lower percentile, and Kayla's is 24, even though she's in a higher percentile. So he had the higher vertical jump. So who was in the higher percentile? Well, that's Kayla. But who jumped the highest? That's Drew. Epic. All right, next one. At TechCore, annual bonuses are normally distributed at a mean of 15,000, standard deviation of 2,500. At DataNest, bonuses are also normally distributed with a mean of 12,000 and a standard deviation of 4,000. At TechCore, only the top 20% of employees receive a conference stipend. Find the minimum bonus needed to qualify. At DataNest, the top 30% of employees receive the same benefit, the conference stipend. Find the minimum bonus needed there. Based on your calculations, at which company can you earn less and still qualify for the bonus? Interesting problem. All right, mean is mu, expected variability, sigma. X is the raw score. Standardized is the z-score. And we're looking for probability of x. That's what that probability is, probability of x. All right. N is 1, distribution, normal. If you're wondering why we're doing this N is 1 again and again and again, it's because down the road we'll be doing samples where N won't be 1. It'll be, like 30 in a sample, for example. But now we're just doing single values. All right, the shading is going to be to the right because we want that, that which company can you earn less and still qualify for the bonus, because the bonus will be to the people in the right of the distribution. All right, population mean is 15,000 TechCore. Effective variability is 2,500. And we are looking for X, so we don't know it, but we do know the probability that the bonus only goes to the top 20%. So working backwards to a z-score, norm.s.inverse. But it's to the right. So it's going to be 1 minus p of x. 1 minus that probability. And the raw score that corresponds to that is going to be equal to z times standard deviation. So effectively we're taking the z-score and making it a raw score plus mu. So if you earn 17,000, it gets you in the top 20%, you qualify for the bonus. That's at TechCore. Now let's see what happens at DataNest. Also going to be to the right. Population mean here is 12,000. Effective variability is 4,000. Probability, it's the top 30% here that get the bonus. So what z-score is that? Norm.s.inverse. It's 1 minus since we're looking right. And then the x value that corresponds to that is z times standard deviation plus mu. So 14,000. So at DataNest, you only need to earn 14,000 and change to get the conference bonus, but at TechCore, you'd have to earn 17,000. Which company gives bonuses to the greater percentage of employees? Well, that's going to be DataNest, right? More area shaded. At which company can you earn less and still qualify? Well, that's also DataNest. Sweet. Okay, next one. These last two are a little bit different because so far we've been looking at sort of overlapping shaded areas. Now we're going to look at shaded areas just on the extremes, in the tails.